Assalamu alaikum everyone, and today we are going to talk about the parabola. So we've gone over two conic sections, that is the circle, which was, come on guys, the easiest one because we knew a lot about circles before we even started graphing conic sections. We learned about the ellipse, which was a slightly trickier one, I would say. Now let's move on to the next one, which will be very important in physics. That is the parabola. It's spelled like this: P-A-R-A-B-O-L-A. Parabola. Now, enough with the English here. Let's graph these, at least see how a graph looks like. Now, if you've heard the word parabola before, or at least heard a little bit of detail about this, but didn't learn the exact details, just a little conversation from a friend or something like that, you might know that the parabola is like a curved shape that opens either upwards or downward. Now we have to go to the features of the parabola, like we looked in the ellipse, in the fox size, and the circle where there is a center point. In a parabola, there is a focus, and the focus is the point at space, and the directrix, which is a line at any point of space. And how it works is that the distance from a point to the focus and the distance from that exact same point to the directrix is the same. So some things like this and these are quite the examples. Now, one thing to mention, when I first learned this, I saw that I get confused with the ellipse. Now let me tell you the difference between this and the ellipse. Now this is the distance to the focus is the same distance as the point is to the directrix, but R1 and R2 adding up is a constant. Means from one foci intersecting a point in the ellipse to the other foci, them adding up in all of these different points would be constant. But here, the distance from the focus and the distance to the directrix will be the same, but they won't be constant as shown. Like here, the distance from the focus to this point and the distance to the directrix to this point is more than the point here to the focus to the directrix. I know a lot of terminology here, you just have to memorize it. Now let's look at the graph itself. So before learning how to graph them, let's look at a graph itself. Now we by this have to understand that every parabola will be a second degree polynomial. Now you must have heard of things like y equals to x squared is in fact a parabola. So you might get confused and say, Uzair, x squared is not a second degree polynomial, yet it's still a parabola. How so? Well, I got the answer to that, and that is x squared plus 0x plus 0 are the same thing. You get it now? This can be expressed as a second degree polynomial, except the lone x term would be 0 plus the constant will also be 0. That's why we can simplify it and write it as x squared. Look up my simplifying polynomials video for more information that we don't need zeros here, because those will just be answered 0, which doesn't change anything, but it can be expressed as a second degree polynomial. Now let's learn how to graph them. Now I have an actual second degree polynomial here, but we can't, graph them like normally, like combining all the graphs or something like that. So how do we do it? Now there are 2 original strategies, but I will use one hopefully in my entire channel, so I'm going to explain that right now. And the second strategy, you might have to look it up. I'm sorry, but the video might get too long. So in the first strategy, we have to complete the square and get this equation into vertex form, which is y equals to a times the group x minus h plus x minus h quantity squared plus k. Now before looking this whole thing up, we're going to derive this equation from an original second degree polynomial. But don't be scared. Don't be like, every time I have to solve this graph, I have to derive this formula every time. No, you just have to derive it once in your entire life, hopefully. Then you have to just memorize it, practice it more and more, and then you don't need to derive it in every single question in your question paper. So a regular ax squared plus bx plus c, first completing the square, we have to put it like this, like take the a from out of the group. So we're putting a times the group x squared plus b over a x. It gets divided so that we don't change the value of the actual thing. Because if you look at some math, if I put it out of the group and in the group and don't change the b, it won't be similar if we try to work with it in real mathematics and not just variables. Sometimes in variables it gets tough too. So just remember that. Alright, now what we have to do is we have to add another thing, which is minus b squared over 4a squared. Now this will be a whole group. But we also have to minus b squared over 4a squared, because we don't want to change the value. If we add something in the group, we have to subtract it something outside of the group. Otherwise, we altered the value, and we don't want the value to be altered. So remember that. So by getting the square root, we get a times the group x plus b over 2a quantity squared plus c minus b squared over 4a squared. Now, by that, we have the vertex form. We have our h, which is this, and we have our k, which is this. And the vertex form is this. So now we have to learn how to graph them in a real equation. So in this equation, we got our h equals to -1 and k equals to 2. When you do the maths for the equations I have just told you, and you solve for it in this equation, you get these two results. And these will be the points on the x and y axis graph. And since a is negative, then the graph will open downwards and not upward. So with that, we've done all the graphs. And remember that parabolas are very, 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 very important when it comes to physics. Because projectile motion would have the horizontal motion and vertical motion, which are independent to each other. So combine the two calculations of the vertical and horizontal motion, we get the projectile motion, which is horizontal and vertical. Like when you throw a cricket ball or baseball while bowling. Here's how a cricket ball goes. And then the ball goes straight in this sort of parabolic path to hit the batsman. So the projectile motion of that is that there's a horizontal motion and also there's a vertical motion, because the ball will have a highest point in space. I just showed you the physics of cricket. See? Who said physics wasn't useful at sports? So with that, we've done 3 of these conic sections and 1 last to go, the hyperbola. But before that, remember to subscribe to my channel to get more of these content of complex mathematics or science. Although they're not in a complex stage now, but soon they will. So get ready to subscribe, so when you get the time, or in a time where you need to learn those complex mathematics, I'll be there to take your back. So, and also you can like this video and comment, is this video actually helpful? So that's all there's to it, to the video. Thank you for watching, and I will see you next time. Bye.